Next, let's solve a question. Here, in this diagram, we are given the xy plane or xy coordinate system, and we are given that if a point particle is at position A at t is equal to t initial, that means at initial time the particle is at point A whose coordinates are 2, 0, and at t is equal to t final, that means at final time the particle is at point B whose coordinates are 5, 3. Now we are required to find the magnitude of displacement and also the angle made by the displacement vector with positive direction of x-axis in anti-clockwise direction. Let's start the problem. Here, let us first draw the initial position vectors, that means Ri vector and Rf vector, Ri vector and Rf vector. After that, we have to find delta R vector magnitude and the angle made by delta R vector with the positive direction of x-axis in anti-clockwise direction. Here, this will be the Ri vector. Let's write the Ri vector. Ri vector will be equal to 2i cap plus 0 j cap. Then Rf vector, this is the final position vector or Rf vector, and Rf vector can be written as 5i cap plus 3 j cap. 5i cap plus 3 j cap. Now we can easily find delta Rf vector, which is going to be Rf vector minus Ri vector. Therefore, delta R vector is equal to Rf vector minus Ri vector, which is going to be 5i cap minus 2i cap, that is 3i cap, plus 3j cap minus 0j cap plus 3j cap. And we can draw this delta R vector. This will be delta R vector. Now we have to find magnitude of delta R vector. Therefore, magnitude of delta R vector will be simply 3 square plus 3 square. 3 square plus 3 square. We have already learned these simple formulas. Square root of 9 plus 9, it is 18, or 3 root 2. This will be the answer. Units, we can write here units, since the unit is not mentioned. Next, we have to find the angle made by this delta R vector with the positive direction of x-axis. That means we have to find this angle. Let this angle be theta. For finding this, we know this will be the y component of this delta vector, and this will be the x component of this delta R vector. We can draw this vector here also in this way. From this figure, we can write tan theta is equal to this. Its magnitude is 3 upon its magnitude, which is also 3. That is equal to 1. Therefore, theta is equal to 45 degree, which is going to be our answer. Theta is equal to 45 degree. Hence, solved. In the next question, we are given this situation where a particle moves from position A to position B in a path as shown in the figure. That means the particle moves from position A to B in this shown path. If the angle between R1 vector and R2 vector, which are the position vectors of A and B respectively, with respect to this origin, that means we are taking this origin as the frame of reference from where we are observing the situation, and this origin is the frame of reference. If the angle between R1 vector and R2 vector is given as theta, then we are required to find the magnitude of displacement vector. Now, the displacement vector delta R vector will be final position vector minus initial position vector. Final position vector will be RV vector, which is R2 vector. R2 vector minus R1 vector. Now, this can be shown by this directed line segment. This is basically delta R vector. So, we have to find the magnitude of displacement. Therefore, magnitude of displacement equal to magnitude of R2 vector minus R1 vector, which we have already learned. We have already learned its formula, which is equal to square root of magnitude of R2 vector squared plus magnitude of R1 vector squared minus 2 times magnitude of R2 vector, magnitude of R1 vector, cos of the angle between R2 vector and R1 vector, which is theta. So this is going to be the answer. Next, we are going to solve question number 3. Here, we are given a particle moves in a semicircular path of radius r from O to A. That means the particle moves from O to A in this semicircular path whose radius is given as r. Suppose this be the midpoint of this line segment OA, and this is going to be the radius r. Then it moves parallel to z axis covering a distance r up to b. That means this AB distance is r and AB is parallel to z axis. That means the particle moves in xz plane from A to B. Finally, it moves along BC parallel to y axis. That means from position B, it moves parallel to y axis and it moves up to point C, where BC distance is given as 2r. Now we are equal to find the ratio of distance upon magnitude of displacement. First of all, let's find the distance traveled or the actual path length traveled. Solution. Let this point be, let's say, D. This D point is lying on the arc OA. So we can write distance traveled or capital D is equal to this arc length OA, ODA arc length plus this AB plus this BC. The summation of all these three terms will give the total distance or the total path length traveled by the particle. So let's find it. Now ODA is going to be pi r. Its length is going to be pi r because it is a semicircle, plus AB. AB distance is given as r plus BC distance is given as 2r. So here we are getting, if we take r common, then pi plus 2 plus 1, 3. This is going to be the distance traveled or D. Now we have to find S, that is the magnitude of displacement. For that, let's write the coordinates first. Here, the coordinates of origin is 0, 0, 0. Now let's write the coordinates of A. It is going to be, since the point A is lying on the x-axis, its y coordinate and z coordinate is going to be 0. Now its x coordinate is going to be this length, which is 2r. Because this length is r, so and this length is r, so together this OA is going to form 2r. Now the point B is lying on xz plane. That is why its y coordinate is going to be 0. Now we have to write its x coordinate and z coordinate. Since the point B, the line AB is parallel to z axis, the x coordinate of B is going to be the same as that of A, which is 2r. And its z coordinate is going to be r because from the point A, it has moved it by distance r in the direction of z axis. Now let's write the coordinates of point C. The x coordinate of B and C is going to be same, which is 2r. The y coordinate is going to be 2r because from this xz plane it has moved a distance 2r along y axis. And the z coordinate of this point will be same as this point, which is r. Now we know the coordinates of C and O. Therefore we can write displacement vector delta r vector is simply the final position vector. The final position vector is RC vector minus the initial position vector is RO vector. Now RC vector is basically, since the coordinates are known, we can easily write the vector 2r I cap plus 2r j cap plus r times k cap. This is the final position vector when the particle is at point C, minus initial position vector will be 0 I cap plus 0 j cap plus 0 k cap. 0 I cap plus 0 j cap plus 0 k cap. Therefore, we are getting delta r vector as this 2r I cap plus 2r j cap plus r k cap. We can rub this quantity. Now we are requiring S, which is basically the magnitude of delta r vector, which we can easily find using the formula 2r whole square plus 2r whole square plus r square. Let's rub the board. Here we can write S is equal to 2 square 4, 2 square 4 plus 1. That means 9 r square. And it is going to be 3r. Therefore, we have got S, that is the magnitude of displacement, and we have also found the distance traveled. Therefore, D ratio S or D upon S is basically R times pi plus 3 upon 3r. Here r get cancelled, so we are getting pi plus 3 upon 3. This is going to be the final answer. Hence, we have solved this question. Here in question number 4, we are given a particle is moving in a circle of radius r. That means the particle is moving in this circle whose radius is given as r. The first question is, what is its displacement when it covers half the circle? Let the particle start from position A and it is constantly moving along this circle. Now we are required to find the displacement when it covers half the circle. That means when it moves from point A to B, and full circle, that means from when it moves from A to A. Let's solve the first question. After that, we have to find the distance traveled when it covers half the circle and full circle also. The first part A. Now, when it covers half the circle, let it reaches the position B from A. That means when it covers half circle, the displacement vector is going to be this vector. Therefore, the magnitude is going to be, here we are required to find the magnitude of displacement. It is already mentioned in this question. Therefore, in the first case, the displacement, the magnitude of displacement is going to be this, the magnitude of this vector, which is simply, we can see 2 times the radius of the circle. The second problem is, that means we are required to find the magnitude of displacement when it covers full circle. That means when it moves from position A and reaches position A. Therefore, delta r vector, its final position vector will be same as initial position vector. Therefore, we know delta r vector as final position vector minus initial position vector. So it will result in 0 vector, which is, therefore the magnitude is going to be 0. Now, let's come to question number B. Here we are required to find the distance or the actual path length traveled when it covers half the circle. That means when it reaches the position B from A, that means in this direction, the actual path length covered will be this length. This length is, as we all know, is pi times r. So we can represent distance as D is equal to pi times the radius of the circle. Now in second case, that when it covers full circle, that means it moves from position A and it reaches the position A by covering this actual path length, and we all know this is 2 times pi times r. Therefore D is going to be 2 pi r. This is going to be the solution of this question. Now let's note some important points. The first point is, distance between a given set of initial and final position can have infinite values, but displacement is always unique. Let's understand this statement using a diagram. Suppose the initial position is this point A. At t is equal to t initial, the particle is at position A, and at t is equal to t final, the particle is at position B. Now, we are given these initial and final positions. From A to B, there are infinite paths through which a particle can reach the position B. Suppose this can be one path, path number 1. This can be another path, path number 2. This can be another path, path number 3. So there are infinite paths, means there are infinite path lengths. That means there are infinite distances between A and B through which a particle covering this distances reach from A to B. Now, whatever these path lengths be or whatever these paths be, the displacement is always going to be unique. The displacement is always going to be this vector, this AB vector, or you can say delta R vector. Where if the it does not matter whether the path length is P1 or P2 or P3, the displacement is going to be this vector. This concept is being said by this statement.